you are, you should start. And what do we know about serialization from what we've seen in class? You already have learned something, for those of you who've tried serialization. And what we're going to end up doing here is I want to go with you. Okay, so you'll be implementing and I'll be discussing at the same time. Okay, it's not as if I'll finish everything and then you can implement later. I had to work very hard to go and present things in the same order in which I'm asking you to implement. Okay, so we know, and we want to talk about how to do serialization not just in Gypsy but in general algorithm. Okay, and the pros and cons. Okay, so we want an algorithm like theory guys, but these are not complex algorithms. So we want to add some more concepts by looking at trade-offs also. Okay, so we know that we have this object input stream and object output stream, and this is used to deserialize something, and this is used to serialize something. Okay, and we can create these streams from other streams, from output streams and input streams, and that's what we tend to do. That from a socket's output stream, we create an object output stream, and we can then write an object to it. And from an input stream, we can create an object input stream and read objects from it. Okay, so that's what we know about serialization. Plus, we know how to extend it. Now we want to go and see what's going on in these classes. Okay, how to implement it. So we're going to have a recursive algorithm, right? And the recursive algorithm is going to be visiting nodes in a tree. And we'll start with some top-level node, which is the object we're trying to read or write. Okay, and so we have that node as an argument. And this is the byte sequence that we're going to either serialize into or deserialize from. Okay, so it's a reference parameter. Either we are filling it up or we're reading it. That's what's underneath going on. Okay, so we've got our header. Okay, now what are the steps here?
So you could depth first search through the rest of the tree until you hit the bottom, like where you're at the kind of type, and then start building it back up into the root.
Okay, so we're going to do a recursive algorithm, and recursive algorithm will be depth first. Okay, so that's good. So somewhere here, I'm going to have a recursive step.
Right.
Somewhere here, I'm going to have a base condition. My base condition is going to be some atomic type. So I use primitive, and just before coming here, I changed primitive to atomic because a string,
Yeah, strings are.
we will go and serialize as one chunk,
Yeah.
even though it's not a primitive type. Okay. Okay. So anything else we have to do?
We also, every time we do that, we need to keep some information about what it is we just serialized and how big it is, because if it all ends up as one byte sequence, we need a way to delineate it back into.
Okay, so when we deserialize, we have to go and break it up into chunks, right?
Yes, we have to.
Somewhere we have to put chunk boundaries.
Yes.
Excellent. Huh?
Byte buffer
So
sizes.
you give sizes. Okay, so size is clearly, I clearly need to know that, from here to here is serialization of some primitive value. When I'm deserializing it, what else do I need? I want to serialize, I'm serializing an object of certain class. I'm going to deserialize it into an object of,
Presumably the same class. So you need to compare.
so I maybe need class names. Okay. Now, do I need to,
You won't need variable names, right? Because you can just say, oh, I'm going to serialize the component variables in this order and then deserialize them.
so we can assume, that's the other issue. Are we going to assume a certain offset with each variable and assume that there is some order in which we go and serialize the components, and the same order we can use in deserializing also? Or do we are more conservative and we go and put the component names also?
We
Okay.
can actually sort it in alphabetical order.
We can do it in alphabetical order. Yeah, I mean that's the safest way. Okay.
So you don't have to store names.
Yeah.
You can just do it in a sort of instance name.
Actually, if you are doing, there's even a better way than that. Yeah.
Could you do a map of field names? Since you can serialize a map, you can transfer the map over.
So you can pass the field name along each time. That's what a map really means, right? Map means there's no order.
Well, no, I mean an actual map object.
Yeah, the map object is going to have names, right? So these guys don't want to send names.
No, you don't want to send.
We're saying, can we get around
Use
it?
the size of the byte buffer. You can just assume that because the class is, you send a class name,
the thing I'm thinking you would need, at least if you're doing the alphabetical thing, you also have to denote boundaries, because there's no guarantee that a string is going to be the same size.
Yeah, the boundaries will have to be there. Okay.
No, but that depends on how you serialize a string, right? Like if I say like I'm reading a string, then I assume that I always get an int, and then I can read on that many parameters.
Yeah, sure, that's fine. But so that's effectively about.
So when there are variable component sizes, you want to go and put some value there to give the size. When there's a fixed component size, you don't have to give that. Right?
String is the only like variable thing we have.
Well, what if you're serializing an array, a list? Okay. And the other thing is, you guys are assuming variables. We might do variables, or in your project, if you read further, you're doing properties actually. And you can also go and assume that whoever's telling you about the fields and properties will give the fields and properties in the same order at both ends. Somehow you discover the fields, right? Some API you called. That call is going to give you the fields in some order. It'll probably give you the fields in the same order at the other end too.
You can't guarantee that, though.
Well, it depends. Java might guarantee that. That's how I did it, by the way. And I did, but of course I ran it only on one computer.
Get fields doesn't say anything about ordering.
Well, yeah, get declared fields in your reflector.
I know, but you try doing it 1,000 times and see whether you'll get them in a different order. It's not, it's going to go and read it from some file in an order, right? It's from the class file. So I didn't even do the alphabetical. I thought about doing the alphabetical sort. I said, let's just do it this way and see whether I was curious to see whether it works or not. Okay. Okay. Anything else?
You might want to put a check in there for things that can't be serialized.
Okay. So that's somewhere we'll do that. Okay. And
What about
cycles.
You need to maintain a table of objects that you've already serialized so that you know you're not going back to the same line.
Table or list? Maybe we're going to pass offsets. We're going to pass offsets. That offset will be the position in the list.
Or you could just do the toString of each thing you're about to serialize, because if you do its object toString, then it'll give you its name and memory offset, or its type of memory offset. So there's
Unless you've got a more clever two-string.
Yeah. And actually, that's not a memory offset.
or what is it?
It's just some number. I don't- Yeah, it's more like an
Oh,
ID.
okay.
What's the hash
So,
code?
yeah, is it the hash code? I've tried that. There are two hash codes also. There's the system identity hash code and the regular hash code. Hash codes can change. Hash code can change. The system identity hash code doesn't change, as I found out.
Also, like with cycles, like if some the hash codes are themselves, and then like you can get Stack Overflow from calling the hash code because of this.
Yeah. So you're saying that if you call the hash code,
So, like the hash code, like use the hash codes of the objects inside the list. for
that in
example.
Gypsy.
Well, I tried it, and then so like the default like hash code of like the list would like does like call the other one.
Oh, so the hash code
Yeah,
recursively
calls
calls.
the
the
really?
hash codes or things that are-
Ah.
So I initially tried using hash
Genius.
code to like determine it, and then like okay, I need another identifier. So
Yeah. System identity hash code. That's what you want. You say system.get identity, something like that, and that's that. Just look for system identity hash code. That's a unique number. Okay. But that's just a question of putting it into a list. If you just put it in a list, you can just go and check with the, you can just search that list. Okay. So let's go and see. I'm going to handle something at the top. Handle header node byte sequence before I do anything. And this is going to do what among the various steps we talked about? What could this be doing? Before I go, so I'm visiting a node, and I'm going to do something. Get class, type that, or maybe check for recursion. Okay, we're going to do the recursive part later. Okay, so we just got, the cycle part later. Then for all components, C, handle component, header. Okay, this is where I might put a name or I might not put a name. Okay, there are pros and cons. And I might be serializing from one language to another language. And so the alphabetical might still work, but I can't just assume my Java giving me the fields in the right order.
what is the headers here?
So I'm going to put some, remember we were going to put the type name?
Right.
So this routine just does something before it goes to all the components.
Okay.
So it's just handling the header kind of information, the stuff that comes before the children. Okay? We're going to delve into each of the routines later. But you want to do something with that
Okay,
node.
So you're just like
Processing.
the object before you start diving into the next
It's a,
or the child.
And typically you'll be writing header information. Hence I said handle header.
Okay.
so it's just like your bookkeeping before you start.
Bookkeeping or just putting in your type name. Right? Handle component, header. And then I go and see whether my component is atomic or not. Handle atomic. Or I recursively call myself. Okay? So far so good? You guys are basic. And what is serialization versus deserialization? That you have a reference parameter, you're either writing to it or reading from it. Okay? So you're basically, if I have another BMI spreadsheet that's going to be serialized into another object of the same class, the other object must be able to create an instance. I can use new instance here, class new instance, that's something you will need. And I just have to go and pass something that denotes the class name. Okay? So the serialization of an object consists of the serialization of its type, followed by a serialization of its value. And the value is composed of then the children's types and values and so forth. Right?
I'm looking at this assignment and I feel like I'm about to be shipped off to war. This looks terrible.
When you join grad school, in many places you join grad school to avoid going to war. You go to South Korea,
Sometimes it was a good choice.
a lot of people during the Vietnam time went to college for that reason.
Yeah.
So
So in this picture, like you'll have your.
it's a recursive algorithm. It's a joy to write. Sorry.
So like in this one, the view would be if we looked at the value serialization, it was a compound object. It would have its own block of both of these, like type ID serialization. Okay.
Absolutely.
And it just
Absolutely. And I'm telling you guys what's happening. Imagine that you had to do it all on your own. Okay? Okay. Now, do you always need, let's go and be stingy like these guys are. Do I have to really pass the type? I mean, my type is java.lang.string. Oh my God, that's a lot of bytes. Java.lang.int, and I'm passing one little int, and I'm passing this long string, which, yeah. So can we avoid sending the type?
Since you're taking specific actions on all of those atomics, you can have a big switch somewhere, you may as well use an enumeration.
No, but I need to go and pass. You see, I'm passing from one computer to another computer. I need to go and pass something that both computers understand. So in enum, you're saying you just go and, okay, I can understand enums for the ints and other things, that I go and have, not enums, but just some codes. Enums are not going to go across the language, across the computer. But I can have ID0, ID1, ID2, ID3 for the predefined types. Okay? But what am I going to do for MVC, my MVC class?
That's another question. There might be a class that's in a package on one computer.
Yeah, I get into those issues, let's assume that doesn't happen. Huh? RMI won't allow that.
Okay, so we can assume that isn't, because that was causing a lot of problems. I was trying to trying to find a way to split it up into dots.
No, the class, if the class is in a different,
Basically split it along dots and just take the last one as the class.
if a class is in a different package, it's a different class. New Delhi in India is different from New Delhi in Indiana, right? They're just different things. So it's just a different class then. So, but the question is, can we get away with passing no codes, no enums, no strings at all?
If our type forces an order on the things that come after it.
And forces the types also.
Right.
Okay. So in fact, type ID can be string or some other well-defined identifier. You guys are free to go and have fun with this. Okay. Type is optional if we can. So originally, this serialization stuff happened in the context of remote procedure calls. And that means from the procedure call, I knew what the parameter types were, right? all I had to do was I'm serializing this procedure and deserializing this procedure, and then I knew what types they were. And these types are not polymorphic. So we just knew what exact types to have. So this is not required, it's just required in the context that we are doing things. Okay? So now the question is, we've got the type dealt with. Now what about the value serialization? Right? And let's go and see what happens when you are atomic. Okay? And remember, we have the notion of, on this end it could be little endian, and the other side it could be big endian. So we're going to have some network independent representation of these values. That's something that we have no control over, that the world has agreed on. Okay? And hopefully, whatever language, whatever OS you're using, there are some hooks to go and get these values done. And in Java, in the assignment, how can you access these routines? You haven't read the assignment far enough?
Oh, like you're saying right in the buffer?
Yeah, in the buffer there's write int, put int. It's just doing the XTR. There's put in, there's get int, put string also, I think, get string.
No, there's no. I don't think there's put get string. I think it's put UTF, which I guess is the same thing. Maybe. Can't remember.
I doubt there's no put string. But anyway, I think I've given you all the routines there.
What if you hit a collection?
Collection is not atomic.
Then you just serialize the collection recursively.
Recursively, right?
And there is no method to put a string. What you need to do is take a string and get the byte.
Ah, exactly. You do that. Okay. I'm assuming that does it in the correct order, independent of the machine. Okay. Yeah.
But if you, I can see, don't you at least have to have something for an array? Like,
Really?
I can see if you
Size of
serialize a
array,
linked list, like how it'll go, but if you serialize an array list, you're eventually going to get down to an array.
And we will write the array serialization.
Okay.
And then you deserialize on the other side by saying array list, put all of these values.
And for all I know, they expect strings to go character by character by character. For all I know. Okay. But I think, yeah. So then there's no issue because there's no little end. Yeah, we're down to the character level. So I think it's safe to do what we were talking about.
No, now the problem is if you're the other language you're sending to, assuming you're going cross-language barrier.
Yeah, well, that's,
It's nulls and things.
Then you send strings. Okay. So this is atomic. Okay. So let's go and see this. So this, and you can send binary values, or you can send textual values. And as computer scientists, would we ever send textual values? That's what happens today.
Well, that's the only cross-system representation that's uniformly accepted.
And you want to make calls over HTTP channels. And they only take
Well, you have
strings.
to make an agreement on that part.
No. The main thing is you want to do RPC through the web.
Right.
Over the HTTP protocol, which is all text-based.
So you just have to do a bunch of integer dot parse int and all that good stuff.
Now, who cares about it? We've got to get Intel's processors selling, right? And for debugging, I would almost recommend that you have two sets of routines. The first one's just do strings, and so that you can at least go and see whether you're, because it's human readable.
Well, what if we just made a giant string and then turned that into a byte array and sent that?
That's essentially
what you're gonna do.
Oh, okay.
that's what you'll essentially end up doing. But I'm not saying do you do that. I'm going to make you time things, and see how your serialization compares with the serialization I do. Okay. And so, and how many bytes it sent, because we can figure out how many bytes that were sent also.
If you get a string builder, you can probably just,
That's why there are three parts to it. Divide and conquer. Okay, I'm glad you're scared. That was my goal.
Can we assume that the byte buffer is
that's the quota today for Halloween.
The byte buffer will be sent by NIO. You'll create the byte buffer, and then NIO will send the byte buffer. So textual versus binary atomic values, inefficient, human readable, debugging and logging, and heterogeneous platforms can be sent over SMTP. And I had this great idea when way before web. I'm going to do RPC over mail. And I don't know whether somebody did it or not, but I thought that was an excellent idea. Because I had built this RPC system, and I said, and I had this distributed object system with persistent objects. So there was always, the other process was guaranteed to exist. And, just send it across mail. It'll reach there. And for some applications, that's fine. Humans think slowly in certain contexts.
I'm pretty sure that.
I like this idea that.
Do you think that was done?
I think so. I remember reading somewhere that companies just did it that way.
Okay. I mentioned this thing earlier in class, though. So that might be from there.
I like this so much.
I just can't imagine somebody going to such extremes. Because in a distributed object system with persistent objects, it makes sense. The thing is that if I'm going to go and send, or you're assuming that the debug process is always there, maybe. And then how is the result going to come back? How do they go and name the receiver? Because there's no socket channel. So in my world, every process had a file name, and it was persistent.
Or does every process have an email address?
So you'll have to build this whole infrastructure.
Okay.
And I just don't think anybody went as crazy as I did, in my mind.
I like that.
Yeah.
Because, it definitely abstracts out the idea that IPC is really just message passing. So let's just use a protocol that's designed for passing messages around.
Absolutely. So, atomic serialization, we are fine with. Components. And now, before we get into components, the question is, what kind of components? They're the physical structure and the logical structure. And I just got some slides I'm going to go through because you guys have all seen logical structure, but in case your cache is not fully populated, just go through the slides. We saw that there was, and there were properties, and they're not the same. And there's a that you all guys are familiar with, and in case of a sequence also, and that's what you're getting into again and again, the array list. What are we really sending? And are we sending the array, or are we sending the elements? If we're sending the elements, we're sending the logical structure. If we're sending the array, we're sending the physical structure. Okay. We'll just use, we will use certain conventions for your project for the lists. So, we've got these two kinds of things. Now, let us go and figure out how to, assuming we make the choice one way or the other, how do we derive the physical components? How do we derive the logical components? Okay. Now, how do you think? Let's go and figure out first physical, which is what you don't have to do. But how do you think it happens in Java? How do they extract the variables from an object? Assuming that this is written above the language.
Reflection.
So reflection will give me the.
Declared fields.
Sorry?
It'll give you all the declared fields in the object as a list.
And I can get the private fields also?
Oh, yeah.
Yeah.
You guys all knew this?
And you can even
Reflection
check
is, when you get to reflection, all bets are off. You're just in there.
So array elements can be accessed directly if we have arrays. But if we have a programmer-defined objects, then we have to go and look at the variables. So can we do this in a repo? And there's get fields and get declared fields. And get fields gives you what? Right? And declared fields gives you
Everything.
all non-inherited variables. So you've got to go up the superclass hierarchy. Okay? You don't have to do this.
Everything just moving around here. You're recursing into an object, you're going up the
The
superclass.
hilarious part is that this probably isn't a ton of code, but
It's probably not very much code at all. It's just
it's
very
interacting
subtle
with
code.
everything else.
And it's a bunch of cooperating recursive routines in different objects. It's not all confined to one object. That is where your head will hurt. Okay. By the way, so if I get a
We're done with this part today, right?
Yeah, you're supposed to finish it by then.
Okay.
Wait, this is only for part 2?
Yes.
Yeah.
we haven't done any recursive things.
Well, wait.
Recursion is when we go to recursive, your head will really hurt. Okay.
So wait, there's more in part 3?
Yeah.
Not
Yeah.
this?
Oh, yeah.
Part 3 stuff, the hard part.
There are 120 slides. Okay. Slide 30. And
For part 2, the one that's due today.
I don't remember what part 2 is.
I think part 2 is implement the serializer.
Yeah.
But for just
But
collection
but
of math.
only we had
Oh, so just regular predefined types.
Yes. We had to implement it for integer, double, string, and collections.
Oh, okay, that's better.
No, it's recursive, so you don't have to worry about fields and so forth.
Right.
Okay, but for logical structure, I've given you some things. Okay, so I've done the hard work. I try my best to have your pain by gain ratio to be as small as possible. That is my goal in general in giving assignments. So you have to. The pain is how much work you had to do. The gain is how many what concepts you've done. If you do a lot of grunge work, that's just pain without any gain, right? Okay. Now, if I get all the fields, can I just go and set them? Can I go and set a value and read the value?
Yes.
You have to. You have to go in for private fields and to say set accessible to true. So if you are going to break encapsulation and you really, really want to break it, you have to do a lot of work. Okay, it's like to remove the seat belt. You have to go and take a fire, burn the belt, do this. And then when you have a crash, I mean, come on, you deserved it. Right? Right? So this was the difference between the C programming language and the Xerox programming languages. And Xerox got it right. Xerox said, we'll give you by default a very safe language. But when you want to break and write an operating system, we'll make it hard for you, but possible. C said, we'll write for the operating system guys. When you want to write decent, just regular programs, we'll make it very hard for you. When you want to write these OS programs, we'll make it very easy for you. Okay? And I think the right decision was with Mesa. Okay? And unfortunately, even today, we don't have a language that can do both. I mean, Mesa was a Xerox language in which the Xerox operating systems were implemented. But today we have Java, but you really can't get down to registers in Java. So in C you can. That's why in operating system courses we still use C. Okay. So you can break encapsulation. How to get logical components? We have to look at the methods, right? And to look at the methods, you can get at the methods, and then from methods you can go and look at the signature, and from the signature you can figure out a getter or a setter, and you can look at your pleasure. But here I'm printing at your leisure and pleasure. Print properties of an object. What am I doing? I'm getting all the methods of the object first, right? And then I'm going to say if that is a getter method, then I invoke the method in some way. And if it's and so this is I'm printing. So just looking for if it's a getter or not. So here's a class. Okay, so if you don't know, the class is also an object. And what is its class? Don't ask me. There's all kinds of interesting issues there, but it's class. Class is object. Class is class. Okay. And you can then get its methods. And I know some of you haven't done reflection, so this is for you. And you go through all the methods, check if each method is a getter or not, and we'll see how we do the getter. If it is a getter, then you invoke the method with the object on which you want the method to be invoked, the method itself, and no arguments because it's a getter. And then you can go and print out the property name which will derive from the method. Right? Because from the method you can get its name. Here I'm doing, I'm checking the parameter types and so forth to see if it's a getter, and I'm doing something similar with name to figure out if it's a property name. So and I'm finally going and invoking the method. Okay, so this is something that I'm just providing you with. You don't have to use. Okay, so you can do reflection. Is there something higher level you can do to find out all the properties? In Java, there's reflection and there's something else with the ION. Some abstraction on top of reflection, which is preceded by the word bean. Bean introspection.
Bean infos. Bean infos?
Yes. Okay. So high level abstraction. Basically, there's some pattern that the method should follow. And we can burn into some object that pattern and provide you with higher level things. Okay, I'll take 3 more minutes because I just need to, this will be useful for you. So you can do get methods, or you can say introspector, which is a class with a static method. Get bean info of class C. Okay.
We can use this instead.
Absolutely. I've told you guys to use that stuff in the assignment. Okay, and you can get all the property descriptors. So it's going to do all the getters and look at the method signatures and so forth. Okay, so again, your pain ratio is low. Okay.
Basically, bean infos are just property names and they get essentials.
Okay, so now it's probably descriptive. You can get read method, set read method, get write method, and then you can invoke those methods to get the values. Okay, that's how they designed it. If I was to, I would have get object and set object with a component name. Okay, I won't even expose method abstraction to you. Okay, but that's how they did it. But I did. So you can go and check if an object you have it's going to be either a bean or a list. Okay, in our world. If it's not a list, it's a bean. Okay, and for list, it goes and checks if it's a list or not. You can go and say whether the class is list or not. So when you go from part 2 to part 3, this is what you'll need. Then you're going to be serializing and deserializing beans and lists that are generic. You're not going to be hardwired to array list and vector and so forth. You can go and figure out what the size of the list is. You can get a value at a particular index. You can set a value at a certain index. This is all handled for you by this particular code. So you don't have to worry about doing any reflection. This is my introspector for lists. Okay? Right. Why no is bean? Because every object is a bean with 0 or more properties. Okay, so you don't have to. So if it's not a list, it's a bean. I don't know whether I ask you guys to do generic tables or not. I don't think I do. Otherwise, I would have had something for his table also.
The table you mean map?
Yeah.
Yeah, you do.
But I ask you to go from map to hash map or hash map to hash table.
You said map, just map. So you
Yeah.
just map.
So you can just use the interface.
Oh, okay.
Whereas for lists, I'm asking you to go from one kind of list to your own list,
Yeah.
which does not implement the list interface, for instance. You can come in. You know, we can go late also.